This air conditioning unit. Starting to look familiar. This is the unit that we replaced that compressor on. This is the unit that we replaced this low pressure switch on. This unit's been problematic. This unit is scheduled for surgery to get a new TXV because there is a restriction in the system that is probably what caused the compressor to go bad. But I digress. What we've got going on right now is our temperature monitoring system told us that the output air temperature indicated the compressor wasn't running. So I'll put that up and let you see what I mean. This is the output temperature that it's dumping into the kitchen, 72.5. Okay, so we're up here on the roof. Fans are all spinning. I know it looks funny in the frame rate. This compressor is not running, and this compressor is tied into those fans. So if they're on, if one's on, the other should be on. So, couple things. So we're set for voltage, right? So this is the wiring to the thermostat. So R to C is power running down to the thermostat. Yes, it is. Y1 is the thermostat asking for that compressor to run. Yes, it is, but it's not running. Y2, yes, it is. And that other compressor is running. And obviously G is the blower fan, and it is also running. So the way the basic aesthetics of how this looks is Y1 gets told to cool. It runs down here to this contactor. This is first stage cooling. This contactor was replaced by my partner a week and a half ago because it burnt up. Second stage you can see is pulled in. See how that one is out, that one is in. So, and this one is also in. So there's your blower fans, or your condenser fans up top. Second stage cooling, first stage cooling. So first stage cooling is not pulled in. So what we can see is, this is going to be a thing to do with one hand, and I'm not going to be able to do it. So I'm going to put meters on. Okay, so that is the coil. So that 24 volts from yellow is supposed to get to here. It's not. So why is it off? Well, before it finds its final destination, we've talked about these low pressure switch, high pressure switches. Okay, so low pressure switch, power starts on this right hand side. So I'm going to go to ground, and this should work. So I have 23 volts heading into the low pressure switch, and I have 0 volts coming out of the low pressure switch. So I'm off on low pressure. I'm off on my low pressure switch. I'm gonna bet that I don't actually have low pressure. Before I do, so the next thing is gonna be gauges, but I'm gonna do something different because I have a suspicion. So this is my low pressure side, right? So this is normally the cool sweating side. This is your output out of the compressor, your discharge line. So this is hot. Also the, so this has been off. I remember when I first started and I didn't really understand anything about these systems. I'd be like, well, which one's the high side and which one's the low side? And my teacher would be like, well, duh, the cold one is the low side. Okay, this has been off. These are the same temperature. The big one is the low side. High pressure goes out the small tube. Low pressure comes back to the large tube. So this is 24 volts. I want you to remember here. So what I want to do is, now 24 volts can still actually give you a zap, but so I just completed that circuit. I basically bypassed that sensor. So if 24 volts is coming in, it's going right back out, and this should have started, and it did not. So it's not actually a few things. I mean, it could be a few things, but I would bet it's in the wiring, right? So somewhere in this wire there's a short, and it's not just short that's tripping, but it's a short that's not letting the power get to me. I know it's leaving there, and before it gets here, it's not. So we got to open up this panel and chase the wire back and find out where we're losing it at. All right, so I'm hooking up my gauge to the low side. I haven't done anything with chasing that wire. I looked, but I'm hooked up to the low side. I'm on stepper 404, so hang on, let me change this. So this is for multiple refrigerants, so you can scroll over here to 404, 134, 290, 507, 3222, 410. Terrible. Okay. So 240 psi on the low side. We're not off on low, right? If we were out of gas, then that would be our problem. Before I go fiddling with wires, I want to verify something. So power in, power out, power back. Okay. I want to remove these, and I keep this little jumper. So this is going to verify when I put this on if it starts. Press is running, pulling down. So it is definitely, this confirms that it is definitely off because of the low pressure. All right, so now I'm gonna go ahead, because you can see the nightmare of all this wiring. I may, and this you can see we did it here actually, instead of trying to chase this all down, I may just grab new wire. And in this case, I used lamp gauge wire. Don't yell at me, I know. It's overkill, it's just more than you need. And I may just run new wire completely, because it would be easier than undoing all this wire. It chases through there and up and around, and where's it at? You know, nightmare. So I'm gonna give it a go and just take a look and see what I can see. And then beyond that, we're probably going to just pull new wire. Before I run off with my conclusion that I haven't confirmed where the break is and the wires. I've got my new set of wires hooked up. I use these little terminal connectors. I like them for a lot of reasons. One, they haven't failed me yet, so I don't have a reason for them to think they would. Also, if you need to check voltage, you could just stick your lead in the extra, even while it's running. You're good. So I haven't tucked it in the unit or anything. It's low voltage, so I have this low voltage wire I like to use. So I've got it hooked up to the pressure switch. I've got that on the inbound. We'll put this and see. Oh, hear that? All right, so when I make connection, pulls in, 100% confirmed. Our issue is the power is not getting over and back. So now we take this and we zip tie it in, work it through. Okay. So I got my new low pressure sensors hooked up. I've got the wire run down, around, up into this junction, through and out and around to here. We're gonna secure these wires so they can't get rubbed out. But we're running now. Compressor came right on. $120, $119. That's great. Pressure equates to temperature, so 39 degrees means 39 degrees is the theoretical temperature of that coil. And if that coil is 39 degrees, then that's what we're dragging our air across. We should definitely be outputting more than 70 degree air. So I'll get this thing put back together, and I'll put up another snapshot of the new output air the way it's supposed to be. So about 15 minutes later, you can see we have 55 degree output air.